Having covered the different layers, we'll now discuss the different choices the various consensus mechanisms make. Proof of work, a permissionless mechanism. Let's talk about proof of work, one of the most famous consensus mechanisms that can be used for authorship throttling. Imagine I'm trying to send 10 emails a day to all of you, which sounds like spam. You can configure your email server to accept messages only if they have a small proof of work attached. To do this, I write my email, hash it, and see if the hash meets certain conditions, like starting with 3 zeros. If it doesn't, I add something to the message and try again until it works. The same thing happens in Bitcoin. Miners build a block, fill in transactions, and then start guessing nonces until they find one that makes the hash valid. The block is then published. There are some advantages to proof of work. First, it's permissionless, or at least it is in principle. Initially, anyone with a computer could join in, but today, specialized hardware dominates the field of Bitcoin mining in practice. Another pro is that it ties the blockchain's value to a real-world, scarce resource, energy. It also adds a layer of security, as you don't know who will author the next block until it's done, which makes it hard to corrupt or attack them. The downsides? It's energy intensive, which raises concerns about sustainability. Plus, you don't get a regular block time. Blocks could be created quickly or slowly, making it hard to predict transaction settlement. Why would anyone want to go through the trouble of authoring blocks? Well, one reason is altruism. Maybe someone just wants to contribute to the network. Another reason is self-interest. If you have transactions you want confirmed, you can author your own blocks. And finally, there's the explicit incentive. In Bitcoin, for instance, you're rewarded with newly issued Bitcoin when you successfully author a block. Heaviest chain rule versus longest chain rule. Bitcoin uses what's called the longest chain rule. The idea is that the chain with the most blocks is considered the valid chain. There's also the heaviest chain rule, which considers the total weight of the blocks, not just the length of the chain. It was employed by Ethereum before the transition to proof of stake. The heaviest chain is determined by how much proof of work has been done, giving more weight to chains that require more energy to create. Either can be enshrined as the fork choice rule for a particular network, and there are many variants employed in the wild that extend the basic two rules with different incentives. Proof of authority, a more traditional approach. Proof of authority is another class of consensus solutions. It divides time into slots, and in each slot, specific participants are allowed to author blocks. This is different from proof of work because it doesn't require energy expenditure. It's more like running a regular server. The key is that authors are identified through cryptographic signatures, so everyone knows who authored each block. While the system is more energy efficient, it's also permissioned. You need to elect the authorities, which is less decentralized. Additionally, the incentives for honesty aren't as clear as in proof of work, where energy expenditure is a built-in safeguard.